Hi, this is Bruce Kirsch, founder of REFM, and welcome to our Build It Together exercise for an amortization schedule that can support both fixed and floating rate interest, an interest-only period on the front end of the loan, a floor and cap on floating rates, and repayment from multiple sources, a perm loan, residential component sale, as well as a retail component sale. Let's take a look at the entirety of this before we dive in. So our assumptions are here. Annual summary sits below. This section here is all about the rates, and we will use the appropriate rate when we solve for interest in the amortization schedule here. And we have three sections for repayment from three potential sources, and repayment is summed up here, and everything else that we would expect in terms of the counter for amortization period, principal amount, and beginning and end balance, and a tracking column for any repayment that would need to occur from equity should these sources of repayment be insufficient. We're going to actually start in the floating rate section, which is this one here. And we're going to be making reference to our assumptions. And so let's start by selecting cell K as in kilo 8. And what we're trying to establish here in column K is what is the assigned rate for each of these months based on the floating index, which we have on the floating interest rate tab. So we're going to be looking to the current settings for the loan, which in this case we're using SOFR. And we're going to pull in the appropriate rate for each period, subject to floor and cap strike rates, which we're showing here. And these are placeholder values for the moment. We will come back and alter those so that we can make sure that they're working as intended.
Real estate is a very interesting industry. Just in the United States alone, close to $10 trillion of value.
This is the playbook for the business on the shelves of a lot of real estate professionals.
It's interactive.
Digital, mobile friendly. It's going to challenge you from absolutely every angle.
It's time to fast track your commercial real estate education with Refi.
I'm going to give myself some space up here, and let's go ahead in K as in kilo 8 and type in equals the minimum of, and we're going to reference next the cap in L as in Lima 3, and I'm going to anchor that and then take the max of the floor in L2. And now I'm going to enter an if statement to check to see what is the current interest rate index that I should be using in the model. And so we'll say if open paren echo 10 anchored is equal to, and then we'll do open quotes, type LIBOR, close quote. Then we're going to do an index to the floating interest rate tab. What we want to index in this case is the LIBOR series. So I'm clicking over to the floating interest rate tab. The LIBOR series is in column P as in Peter. And so I'll span that from P3 to 123, and I'll anchor that range. And then I'm going to match to the current date. I'll go ahead and get rid of this tab name and then back to the floating interest rate tab to specify the dates range, which is N, as in Nike, 3 through 123, anchored. So that is the first part. The second part is the same, but for SOFR. So I did 2 close parens and then a comma, and now I'm doing value if false. I'm going to just copy all of this and paste it and then change it, as opposed to clicking back and forth again. So I'm copying, going to my new line and pasting. And now instead of P, it's going to be Q. And I'm going to close out with 3 parens in addition to the 2 that were already there. So there's a total of 5 close parens. And I'll hit enter. And I've frozen my screen here in row 7 so that when I do my copy and paste down, I can still see my headers. And what we see here is the rates populating down. Now, you may have noticed that the Chatham data gives us 10 years of data. Our amortization schedule here goes out for 30 years. So the way that the index function works is anything beyond the scope will take the last value as opposed to giving an error, which is what VLOOKUP would do. But since we have a floor of 4%, it's going to end up showing 4% instead of that last period value here for SOFR of 3.1. If we lower the floor to 3%, we would see the 3.1% populate. And we can hard key over this to test that. And you see now instead of 4 in those outer years, it's 3.1. If we want to gain a little bit more confidence that we're getting the right numbers, we can pull in the SOFR in column J here, just for the sake of illustration. So you can copy this second part of the formula and drop it into J8, put an equal sign in front of it, and that's going to pull in your SOFR rate, and then copy and paste that. And again, when its SOFR is 3.1 and the floor is 4, the floor is going to dominate. So that gets us comfortable with how our base variable rate column is working. We can also manipulate the cap and say, well, what happens if our cap is 3.5? You can type in 3.5, and you see that that becomes your cap, even when SOFR is at 5. And the same goes for LIBOR as far as the floor and cap mechanics. Next is column L, which is our spread that we're going to add. And this is simply going to be in cell L8 equals L6 anchored divided by 12. Copy and paste that down. And once we have the base rate and the spread, which is showing as monthly, 4% is your annual spread, 0.33 is your monthly spread. We model cash flow monthly, so we're converting from annual to monthly here in order to produce monthlies for each of these, which can then be applied to the loan balances in each month. So now that we have that, we can solve for the three rates on the 30/360, actual 360, and 365/365 bases. For 30/360 in M8, this is simply going to be equals K as in kilo 8 divided by 12 plus the spread in L8. And no anchoring needed here because we want to reference the unique values in each month. For actual 360, we're going to reference M8, which is the floating rate, multiplied by 12, and then divide by 360, and then multiply that by the forward period month beginning date minus the current period month beginning date. So what we're doing here is we are annualizing the 30/360, then dividing it by 360 to get to daily, and then multiplying the daily by the actual number of days in between the 2 month beginning dates. And last, for cell O is an Oscar 8, we're going to reference M8 again, multiply it by 12. Now we divide by 365 and then multiply by the difference in the number of days from the next month start date to the current period start date. And then copy and paste. So that gets us through the floating rates. The good news is the fixed rates are a heck of a lot easier. And so let's go ahead now and step into cell G as in golf 8. In G8, we're going to reference the fixed rate in F6, anchor that, divide by 360, and then multiply by 30. And copy and paste that down. In H8, we're going to reference G8 times 12 divided by 360 times, once again, the difference between the next month's start date and this month's start date. And in I8, reference G8 times 12 divided by 365 times the difference in the dates again. So if you're wondering which one is the best to borrow, it's the 30/360. And this would be the highest cost, the actual 360, with the 365 in the middle. with all of the rates put in place, we can zoom out now and make our way over to the amortization schedule itself. So I'm going to get rid of this frozen pane, and I'll actually refreeze it here at column G so that I can keep the dates in view, but make this a little bit easier to see, like that. Let's start in cell R's and Romeo 8, and what we're going to do in this column is show, if it's an interest-only month, the shorthand IO, and if it's a period of amortization, we'll give the serial number of the month of amortization. And so we can do the following. We can say in R8 equals if the interest-only period anchored times 12 is greater than or equal to the current loan month number, then return the text IO. Otherwise, take the current loan month number and deduct from it the number of years of interest only times 12. And so what this is going to produce for us is, in this case, since we have 1 year of front-end interest only, 12 months, we'll see the shorthand IO, and then in month 13 you'll start to count month 1 of amortization and count up from there. And so there we have it. Next is beginning balance in S8, and we can write the following. If the loan month number is equal to 1, then the beginning balance is the loan amount anchored, comma, if the prior period ending balance is equal to 0, then the beginning period balance in this period is therefore 0. Otherwise, return the prior period ending balance. And all these show up as 0 because currently everything here is still 0.
I wanted to have an impact on decision makers when I was young. I embarked on learning about real estate from some of the industry legends. I'm an economist by training, educator, an investor, and consultant.
Buildings fascinated me, even at a very young age. For more than 10 years, I've dedicated my career to teaching.
This class will help you master the tools of real estate, finance, and investment.
The most rigorous and comprehensive course on the market today. Gain an edge and get certified.
Okay, now we can move to interest in cell T as in Tango 8. And I'm going to give ourselves some room here because we've got a little bit of a whopper. And the reason that this is so involved is because we have different rates that need to be applied based on whether we have a fixed rate or a floating rate, and then within both fixed and floating, the basis of the interest calculation for each. So we're going to have a little bit of an involved formula here, but we'll take it one part at a time. And I'm going to zoom out also a little bit so we can see our interest areas here. Okay. All right. So in T8, I'm going to start with the following: equals if S8 is equal to 0. Okay. If the beginning balance is equal to 0, then there's no interest by definition. Okay. That's the easy part. Now we get into the more complex part. And I'll do an if error, open paren, if open paren, and I'm going to test now to see, is this a floating rate or fixed rate? And I'm first going to say, is it floating rate? And if so, I'm also testing to see, is this period, which is in column R, an interest-only period? And be careful not to type a 0 here when you mean to type a capital O, because that would mess up the logic. And I'll close out the AND function parens, comma, and then I'll start with the next line using an HLOOKUP function. I'm going to put in the proper protection so that we don't have any bad outcomes, and I'll show you how to do that. And we're going to look to the lookup value in Charlie 10. That's a designation of which of the 3 interest calculation bases we're using. And now I'm going to, because we're in floating, span from M6, which is the header for floating, through Oscar 8. And I'm going to anchor M6, but not anchor Oscar 8. And I'll put in the rows function here to give myself the bulletproofing for the HLOOKUP function. And I'll put the false argument in at the end, which means I need an exact match. And then I multiply by echo 9, which is my loan amount. That's my first combination. If it's floating and the current period is interest only, multiply the rate by the total loan amount. Next, if open paren and, again, B10 is equal to floating. I'm going to copy this whole thing up here, bring it down here, but now instead of saying if it's equal to interest only, I'm going to say not equal to interest only. Close out the and now if it's floating but not interest only, that means it's floating and amortizing. So I'm going to use the negative IPMT function. I'll put this on the next line and then run my HLOOKUP again to this C10, and again for all of this is the same. Through the end of the HLOOKUP. Okay, that's the first argument of the IPMT function, is the HLOOKUP. That's your monthly rate. Next, current period is R as in Romeo 8. Okay. In this first period, because we have IO, it's referencing IO, but it would actually be referencing a number. Next, the number of periods of amortization, echo 12 anchored times 12. And last, the present value, which is my loan amount, anchored. Okay, that's our second variation. Next, we go to fixed rate. If and now we say B10 equals fixed rate. Grab it from up here. Change this word floating to fixed. If it's fixed rate and interest only, then we're going to run HLOOKUP. But now we're going to be looking into the fixed rate columns over here. So we're looking at Charlie 10, but over this range, Golf 6 through I as in Ivan 8, anchoring the Golf 6. That's your array. And then putting in the rows function for safety of the same array. False. Close out HLOOKUP times the loan amount, echo 9. And the last, if and, copy this, B10 is equal to fixed rate, but it's not an interest-only period, then let's run, once again, negative IPMT, and we're going to do HLOOKUP as the first argument for the rate. And in this case, G6 to I8. Okay. Same as before. And rows also G6 to I8. Comma false, close out HLOOKUP, then R8 is the current period, total periods of amortization, echo 12 anchored times 12, and the present value, echo 9. Close out your HLOOKUP. Put an otherwise 0 for the overall logic, and then we're going to close out 1, 2, 3, 4, comma 0 for the if error, and close out 2 more. Are we having fun yet? And let's copy and paste this down. And again, it's going to be showing all zeros because our ending balance is still blank, and it's multiplying by a 0 beginning balance. Let's proceed now to principal, which is cell U8. And this one's going to be similarly involved, but not quite as bad. Okay, let's start out again with equals if S8 equals 0, then 0, followed by if error, open paren if, and open paren, Bravo 10, which is our type of rate, is equal to floating rate, and the amortization period is equal to interest only. Then by definition, principal being paid in that month is 0. Next, if and B10 is equal to floating rate and R8 is not equal to interest only, then we're going to run the PPMT function. I'll put a negative sign in front of it. And for the lookup value of the HLOOKUP function, it's going to be Charlie 10 anchored. The array is going to be in the floating M6 through Oscar 8, same as what we did in the interest formula, just anchoring the front end, and then the rows function mentioning that same array. And a false. So that's the rate. The period is going to be R8. Number of periods, your amortization term anchored times 12. And last, the present value, your loan amount. So that covers all of the cases for if it's floating, both if interest only and if not interest only. And next we will address the cases for fixed rate. We'll start if and B10 anchored is equal to fixed rate and R8 is equal to IO. Once again, by definition, principal is going to be 0. And last, if and, I'll go ahead and just copy this, but change this equal sign to not equals. Then we're going to run PPMT, negative PPMT, HLOOKUP, Charlie 10. Now we're looking at fixed, so G6 through I8 with just the G6 anchored. Rows with the same array, comma false, and then R8 for the current period, E12 anchored times 12 for the amortization term, and again E9 for the present value. Close out the paren, comma 0, and then 4 closeouts, 1, 2, 3, 4, and then a 0 for the if error, and then another 2 close paren. And we'll copy and paste this down. So at this point, we've successfully gotten through the amortization period, beginning balance, interest portion of the payment, and principal portion of the payment. The next that we will address are the repayments, which will then impact your ending balance, which then flows to your next period beginning balance, and all of this is going to spring to life.
The hardest thing about working in real estate is there isn't one right answer, but there are a lot of wrong answers.
Trying to understand what those right answers are and the risk and the opportunities presented by those right answers.
The Refi program is the most rigorous and comprehensive course on the market today, and it's massively multimedia.
We provide great material for you to work hard, and we think you're going to come away learning a lot.
There's no rush with Refi. You get lifetime access to the course. We are with you on this journey, and we will continue to be there for you.
Let's go ahead and start in on the repayment. And we'll start in cell V as in Victor 8, which is any repayment from permanent loan. And we'll type the following: equals negative if and C14 anchored is equal to repaid by permanent loan and F8, which is my month beginning date, is equal to the end of the month of the permanent loan repayment date, anchored, comma, -1, close paren, +1, close paren. Then take the lesser of beginning balance minus any principal paid in this current period and the amount of proceeds coming from the refi, and close out with 2 parens. So currently, while our model is indicating that it's repaid by the permanent loan, the proceeds amount is currently showing 0. So we can certainly test that by overriding that amount. First, let's go ahead and get our ending balance filled in because it's going to rely on repayment. So our ending balance in Z as in zebra 8 is equal to if S8 is equal to 0, then 0, meaning if there's no beginning balance, the ending balance will also be 0. Otherwise, the ending balance is going to be the net of beginning balance, principal paid in column U, and then all the repayments. V8, W8, X8, and Y8. So now that we have the ending balance in, we've got values other than 0 down our interest column and our principal column. This is your interest only period, so there's just zeros there. We don't have any repayment currently because this is at 0. So if we wanted to put in, let's say we do a refi for 30 million, which would include some cash out. So in V4, go ahead and enter 30 million. And you now see in the total here, there's a repayment that's happening. Let's go ahead and look down and see when that's happening. It should be in May of 2026. And that is exactly what we see. And our balance goes to 0. So that's working correctly. Now that I see that it's working correctly, I'm just going to relink this to here. And next we move on to repayment coming from residential component sale. For repayment from residential sale, first thing I'm going to do is collapse this, and I'll freeze the pane here so that I can take a look down and across, keeping the headers and dates in view. Okay, so in W9, so in W8 equals if open paren and open paren, Charlie 14 is equal to repaid from sale, and F8 is equal to EO month the point of sale backed up by 1 month, close paren, plus 1 day, close paren, then take the negative of the minimum of beginning balance minus any principal paid in that month, and the net sale proceeds amount, anchored. Otherwise, 0. Now, currently, we're not seeing any repayment because this reads repaid by permanent loan. We can test it by, in Charlie 14, just typing in the text repaid from sale. And if we take a look down, there we have it. In the month beginning, May 1, 2028, the repayment driving the balance to 0. I'm going to undo this so that it reads again, repaid by permanent loan here. And now let's move on to X8, repayment from the retail sale. For X8, I'm going to return to W8, and I'm going to copy the first part here because it's the same set of triggers. And then go back to X8, paste it, repoint the date reference from W5 to X5. Now I can get into the actual sizing of the repayment. Negative min, beginning balance, minus any principal paid in this period, plus any amount that's being repaid from the residential component. In most cases, the retail and residential are going to be sold together. But in this example, we have a staggered sale. So in the instance it's not a staggered sale, so in this instance, the retail actually gets sold before the residential, and it can only pay off up to the amount of its net sale proceeds, which is X4 anchored, close paren on the min function, comma, 0. So again, we don't see anything currently because this is our setting. But let's change that setting and look at how we can have a staggered repayment of the acquisition loan. And we do this because the sale of a retail component involves transfer of title. Transfer of title is loss of collateral to the lender, and they need to be compensated for that loss of collateral. So I'll go here to Charlie 14 and type in repaid from sale, and then we're going to see what happens. So let's take a look. So in this case, because the retail is getting sold 10 months before the residential, there's a loan paydown amount of $3.18 million, there's still 22 million outstanding. And then when we sell the residential, it repays the outstanding balance, driving it to zero. Now, there is a downside scenario where this sale of the asset is insufficient to pay off the outstanding balance. There is also a potential for a refi to be insufficient to pay off an outstanding loan balance. And so as a result, we include one more column, which would be the funding of any repayment shortfall from those three other sources by equity. So we need to provide for two potential sets of circumstances for a shortfall on repayment. One is if the permanent loan, the refi, is insufficient. And the second is if our sale proceeds are insufficient. We're going to wrap this entire statement in an if error. Let's start with the refi circumstance first, with equals negative if and C14 anchored is equal to repaid by permanent loan. If that is true, and the date is equal to the end of the month of the refi, anchored but backed up by 1, plus 1, close paren. If both of those are true, then the shortfall draw amount from equity will be the net of the beginning balance, any principal paid in that period, and the refi amount that was in fact funded towards repayment of the senior. So that is one. The second is insufficient funds from the sale. And we'll do negative if and the sum of those repayment amounts from sale is less than 0, meaning if there is repayment occurring, and that amount is less than the beginning balance, net of any principal paid in this period. And last, if the timing is greater than or equal to the greater of the two sale dates. Why are we doing the greater of the two sale dates? Because if they're not happening at the same time, we want to search for the insufficient amount at the last point of asset sale. That's the last opportunity that we have to repay our senior loan in full. So we take the greater or the later of those two dates. And if that is true, then the amount for shortfall is beginning balance minus any principal paid plus the sum of repayment amounts. Otherwise, 0, close 2 paren, and then comma 0 for the if error. So we can test this by overriding this with $20 million. And what we see is in the period of the refi funding, if it's only funding 20 million, equity has to step in for the balance such that we can repay the senior down to 0. And I'm just going to relink this to here. And also, we can test this simply by overriding our residential sale net sale proceeds amount. So the retail is repaying roughly 3.2 million of the $26 million loan. So let's say that we only got 20 million here. So in W4, I'm going to overwrite and input 20 million. And so if we take a look down, we'll see what happens is you actually have a third repayment source triggering such that the lender can be repaid in full.